So we have started our discussion on the chi-square test. In our last class, we have also discussed the result of this test. Okay, so I can start from here again. This chi-square is for chi-square test is one of the non-parametric test. Okay, non-parametric test, it means the chi-square test will not depend on the average value, like the t-test and g-test. The average and standard deviation, those are known, so we can apply maybe the g-test or t-test on that case. But we can see that here the chi-square, in this case, the hypothesis is the zodiac signs are evenly distributed across visual artists, and this is our hypothesis. Okay, and here is the alternate hypothesis: zodiac signs are not evenly distributed across the visual artist. Okay, so we want to prove the alternate one. Okay, and as I mentioned in this, there is the statistics part of our data science lecture, is that we always try to reject the null hypothesis or accept the null hypothesis. Okay, so the null hypothesis is nullifiable. So here is also we will do the same thing, and in our previous lecture we have already discussed these things. That is, so we have taken the sample of 256 visual artists, and we can see that we found that the Aries 29, Taurus 24, so Gemini 22, Cancer 19. So that means these are the peoples among the visual artists. Okay, so these are the observation, and then the expected number we will get from, that is the dividing 256 by the number of categories we have, the number of categories of zodiac signs. You can see we have 12 categories. So if we divide this one by 12, then we will get 21.33. So this 21.33 is actually our expected value. So here expected value. Then we have to find out the chi-square statistics. So chi-square statistics, it is original minus of expected then square. You can see original value, this one is 29 for the areas, and here is the expected value is 21.333. So the difference is 7.667, and then square that value. So here is the squared value. Okay, so in this way, for each and every zodiac signs, we have to find out the difference between observed and accepted, and then square of that, and then we have to divide that one by the expected value. So we will get those values, and finally we have to sum up to find out the chi-square statistics. So here is the chi-square statistics. We got the chi-square statistics 0.940. So here, this is our chi-square statistics from our data. Then we can see that this chi-square statistics, we have, based on this, we have to find out the chi-square tabular value, or we can say chi-square critical value. So for tabular value, what we need some need to know the degree of freedom. In this case, degree of freedom means that the categories, how many categories are there? The 12 categories. Usually the degree of freedom equal, that is the number of categories minus 1. So in this case, it is 12 minus 1. 12 minus 1 is 11. Okay, so 11. So from our chi-square table, now we can see degree of freedom here is 11, and then we need to find out the p-value. So we can see here there is our chi-square statistics, the value is 5.049. So this one, we have to find out this value here in this row. So we can see actually it will be in between these two values. between these two values. So 0.575 and 5.578 between these two values. And corresponding p-value, you can see here the p-value is 0.950, and here is the 0.90. That means p-value will be within this range 0.9 to 0.95. So here the p-value will be within this range 0.9 to 0.95. So uh, we can see the p-value is within this range, but what's the p-value is we will discuss few slides later. So at this stage, the p-value we have determined that p-value in this case it is 0.9 to 0.95 within this range. So if a p-value is greater than 0.1, that is usually we call not significant. Not significant. So this is the list. That means if p-value is greater than 0.1, that is not significant. If less than 0.1, that is marginally significant. Less than 0.05, it is significant, and less than 0.01, it is highly significant. Okay. So our p-value is within this limit. We can say 0.95. That that there is more than 90% possibility that uh, this result, the result we got, uh, this result is just uh, we can say uh, the result we got that is 90%, more than 90% possibility that it is the result is just random result, or we can say just by chance result. So if that is the case, then what we have to say? Then that means we can say that that is we got the result. We got this result. So should not reject the null hypothesis. Okay, it is we didn't get the significant result. So we should not, that is uh, reject the null hypothesis. So that means we should accept the null hypothesis. That is, zodiac signs are evenly distributed across the visual artist. It means we have to reject our hypothesis. That is alternate hypothesis. Zodiac signs are only not evenly distributed. So we may think about that Aquarius and Capricorn are the more likely in visual artists. So that means this is not true. This statement is not true because the test significance is actually not significant. So we cannot say this. Okay? We cannot say this. So that means we should accept the null hypothesis. Or in another word, we can say that we should not reject the null hypothesis. So in this case, the p-value, the significance value and the p-value we have already mentioned that the, the p-value is used for hypothesis testing to help to support or reject the null hypothesis. Okay. So here the p-value is the evidence against the null hypothesis. So the smaller p-value, that means stronger evidence, and you should reject the null hypothesis. But we can see that that is, if p-value is high, that means you don't have the stronger evidence. That is weak evidence you have. So we should not reject the null hypothesis. Okay. Uh, so for example, if it is mentioned the p-value is this 0.0254, what does it mean? It means that only 2.54% chance that your result could be random. That means this happened by chance. Only 2.54% possibility. So 2.4 your result you got maybe by chance or randomly. So if a p-value 0.9, it means that uh, you have 90% probability that of being completely random. That means your result you get is just 90% probability that it is from the random results. That means we can say that actually uh, we cannot claim the alternate hypothesis. Okay, so that's why uh, in our previous study, that means in our test, in this test we found that the p-value is within the range of 0.9 to 95. So that means we can say more than 90% possibility that the result we get, those are just from the random. So if 90% chance that there is the result are just random result, so how can we accept that? Okay, how can we accept it? That's why we can see in this case there is the acceptable range are less than we can say uh, zero point 0.1. It means that it can be 9%, it can be 8%, it can be 7%, it can be 6%. So if those are called marginally significant, but less than or equal 0.5, it means that it can be 5%, it can be 4%, it can be 3%, it can be 2%, like this. Those are significant results. And 0.01 means is 0.01 less than, that means it can be 1% or less than 1% chance that the result is significant. Uh, so this kind of significance actually we have to test. That is, from your test result, if we claim something, then you have to mention the p-value. It means that you have to mention the significance level of your data of your test. And sometimes the p-value is associated with alpha level, the p-value. So when you run a hypothesis test, you compare p-value from your test to alpha level you selected when you run the test. It means that the alpha you define, if alpha is your defined level, this is your threshold. You can define the alpha. That means you can say that I will accept the result if p-value is less than 0.05. So it means you set the alpha 0.05 and p-value it will from the table. Okay, so you will get from your data, that means from the table. And if the p-value is less than the alpha value, then only you accept the result. So there is a relationship between p-value and the alpha level. So as I already mentioned that the p-value, it is the significance of your test. That means I usually define that if something, if the p-value like it is mentioned 2.0254, it means that there is only 2.54% possibility that the result you get that is happened by chance, or it is kind of random result. So when the p-value is very there is low, that means your statistical evidence, it is more the stronger evidence you have. So that's why the acceptable, there is acceptable range. Okay? And the acceptable range I already mentioned that you can see if the p-value is greater than 0.1, then it is not acceptable. We call it not significant. And these are the acceptable range. But we can see the more significant here is highly significant. If we get the p-value is 0.01, that means the probability of getting the the result by chance is just only 1% or less than 1%. So that is highly significant. So if p-value is less than 0.5, it means the significant. That means probability of getting the result by chance is 90. We can say just only 5%. Okay, uh, so that's the p-value, and now we have that is p-value with alpha level. So here alpha level is user defined. That means you can set your accepted significance level. That means you can say that I will accept if p-value is less than 0.5. Okay, so that means we can say that if alpha, you set the alpha equal 0.5, if the p-value is less than the alpha value, then you will accept, or you can say this much significance you want. So if this is the case, that means the reject the null hypothesis. Okay, or someone can define like more significant, like alpha equal 0.01. So 0.01 is the threshold for that. That means if the p-value is less than that, if the p-value is less than that, then they will say that okay, this is a statistical significant. That means they set the threshold. This is the threshold. Alpha is the threshold. So it means if the p-value is greater than something that is our threshold, then we will not accept that one. Okay. So like if someone mentioned that alpha, that is alpha is 0.05, and if the p-value is greater than 0.05, then it means that the alternate hypothesis is weak. So we should not reject the null. Yes, please. Oh, okay. So we are discussing here. That means if someone mentioned that this is alpha, the alpha is just 0.05. So this is the threshold that is accepted level of threshold, significance threshold. So if the test result shows that that is the significance, that means the p-value is less than 0.5, then we can reject the null hypothesis. If it is greater than that, then we will not accept the we will not reject the null. Okay, that means that is the alternate hypothesis is weak on that case. So alpha is user defined. Okay, user defined, that means you can set your threshold, and p value is statistical. That means you will get this value from your data and from the statistical table. Okay. So someone can define the alpha equal like 0.01. So define this one. That means he want he want just more significance. Okay, more significance. So that means to reject the null hypothesis, if the p-value is less than 0.01, then only he will reject the null hypothesis. Okay, so that means you want a strong evidence of rejecting the null hypothesis. Okay, so how to determine the p-value? We have already checked that. That is, the p-value is a statistical measure, helps scientists to determine whether or not their hypothesis is correct. So if we use that is the chi-square distribution table to approximate the value of p, then use these tables first finding the degree of freedom. So we need the degree of freedom first time, and then reading that rows from the left to right until you find the first value bigger than your chi-square value. So we have already used that one like here. Okay, so that means degree of freedom, this is 11, and then we have to search our value. So this value in this row, and we can see that this is actually 0.049. So it is within this duration, within this range. So p value will be within this range. Okay, within this range. Okay, within this range. And exactly we can find out also the p value. Okay, there is, okay, it is within this range, but we can find out the exactly. In our previous day, we have I have already mentioned one of the value. That is, how can we? So here is the difference. How much the difference, and here is the difference you have to calculate. And then for this value, what will be the exact p value? We will get that. We can find out that also. Okay. So here, then you will get the bigger than guys. Look the corresponding p value on the top of the column. Your p value is between this value in the next largest value, one immediate of the left one. Okay, so we have already calculated those p values also. Okay, so now I think we can continue our discussion on chi-square test. So we have already shown the result for homogeneous data, but if we have there is many categories, not only one category, then how can we apply our chi-square statistics? So now here we can see that chi-square test in this case. So in this case, we have a null hypothesis, like there is no relation between the marital status and educational qualification. Okay, marital status and educational qualification, there is no relation. Alternate hypothesis is here. There is a relation. There is a relation, significant relation. So no relation, and here is the significant relation. Now for that we have collected the data from different schools, like maybe mid-level school, high school, bachelor, master, and PhD. And then there are several categories, several types of individuals. The several types of individuals in this case we can see never married individuals, and middle school 18, and high school 36, and bachelor 21. Okay, so out of our total 300 samples, so we have collected 300 samples, and out of that we can see 18 middle school never married, and high school that's 36, bachelor 21, masters 9, and PhD 6, and total we can see here the total is 90. And married, we found that is in the middle school we sampled, and 12 we got in middle school married, and high school 36, bachelor 45, masters 36, and PhD 21, total 150. And the divorced here is a 6, the 9, 9 like this way, and widowed 3, 9, 9, and 6 and 9. So total you can see here is the 30 and 30. Okay, and total is 300. And if we calculate the total of different categories, like middle school category total is 39, and for high school category total is 90, bachelor category total is 84, and master's category here is 54, and PhD category 33. Okay, so this is our observed values. That means from the collected data we got those results. But in chi-square test we already know that is, we also need to know this, the expected value. So expected value, how to calculate the expected value. So in this case, we can see 18, this is the observation, but what is the expectation? The expectation in this case, we can see we have total 300, and the 90 for that is never married. So here is the 90 out of 300. So 90 out of 300, and we can see the total middle school is 39. So there is 90 by 300 times 39, it is 11.7. So that means this is our expectation. Similarly, for our the high school, here is the 36 is our original observation. But what is expected? The expected is, you can see here the total is 90, 90 by 300. So 90 by 300 by 90 by 300 times 90. Okay. So here is the 90 by 300 times 90. Okay, so 27. So in this way, we can calculate the expected value of different positions. So here, These are the expected value of different positions. Now what we have to do, the next thing is we have to find out that is the chi-square, and for the chi-square that is observed minus expected divided by expected. So we have to use that equation, and you will get this value, that is calculated value. You will get 23.57. So you will get this value, 23.57. 23.57. That is your calculated, or you can say chi-square statistics. Chi-square statistics value is 23.57. Now what we have to do, you have to find out that is chi-square tabular value or critical point. So if we consider that that is our significance level, that is alpha is 0.5, 0.5. So alpha is 0.5. Then we have to find this value in our table. So in our table, we need to find out this. But to find out this that value, specifically what we need, we also need to know the degree of freedom. So in this case, the degree of freedom will be degree of freedom. To calculate the degree of freedom, in this case, it will be, that is the degree of freedom will be, so we can see that is how many categories are there. That is middle school, high school, bachelor, master's, PhD. So total 1, 2, 3, 4, 5. The number of categories minus 1. So number of categories minus 1 is what? Number of categories, we can say 5 categories minus 1 is just this. This is that uh, times different types of individuals minus 1. So how many types of individuals we have? Never married, divorced, widowed. So we can see 1, 2, 3, 4. So 4 minus 1. Then this will be our degree of freedom. There is 4, here is the 3, there is 12. Okay, so degree of freedom will be, degree of freedom in this case it will be 12. So here is this, that is, it is 12. Column minus 1 and row minus 1 in this case. Okay, so that means 12. So what we have to do, we have to find out the chi-square value. So here chi-square value, chi-square, the alpha value we can see here 0.05. For the 0.05, here is the 12. There is degree of freedom is 12. You can see that the value is 21.026. This is for alpha 0.05. Okay, 0.05. So we got the alpha, and here is that is our p value is there is chi-square tabular value for alpha equal 0.05 is 21.26. Okay, 21.26. 21.26. Okay, 21.26. So here is there is 29.03. Okay, so that means that from the table we got 21.03 at alpha level 0.05. So now we can see that which one is greater, 23.75. So that means the chi-square statistics, this one larger than this value. This value, that is chi-square tabular value. If larger, there is the larger value, this one, then we can reject the null hypothesis. Okay, so we can reject the null hypothesis. That means the chi-square statistics is greater than the value of our tabular value, that is chi-square tabular. So on that case, we can reject the null hypothesis. We can reject the null hypothesis or accept the alternate hypothesis. That means there is significance relation between marital status and educational qualification. Okay, so this is another way to test our chi-square test. Okay? Test chi-square result. So now we have another hypothesis testing method, the ANOVA test. Again, the ANOVA is also parametric test. It is not a non-parametric. That is, you can define the mean value, and also we can say our null hypothesis using those mean values. So in this case, we can see that the ANOVA and t-test, what is the difference? That means t-test can use also parametric test, ANOVA is also parametric test. But why we need the ANOVA? So if we have more than two groups, t-test, actually t-test usually we perform to compare between the two groups. But if we have more than two groups, then we have to apply the ANOVA. So here we can see that the t-test will tell you if there is a significant variation between groups. Conversely, ANOVA will tell you if there is a significant variation among the groups. That means we can say more than two groups. So t-test compares the means, while ANOVA compares the variance of between population. So that means it will not compare the mean but the variance. And you could technically perform a series of t-tests, because you can say there is maybe we have three groups, but you can consider just two groups at a time and then compare those values. Okay, that means using the series of t-tests we can also find out the relationship between those groups. But sometimes maybe you will have many groups, and on that case you have to perform many series of t-tests, so that's not feasible. And another benefit of the ANOVA, that means it will just provide you a single statistic, that is called F statistics, and based on just on the single statistics, you can either uh, reject the null hypothesis or accept the null hypothesis. So the ANOVA, it is analysis of variance, is a collection of statistical models and their associated estimation procedure. Here the estimation is the variations, okay? Variance we will calculate. So the ANOVA is used to find out the differences among various groups. And this ANOVA test is developed by the Ronald Fisher. Okay? Ronald Fisher. So based on the Fisher, that's why it is mentioned that F statistics or Fisher's statistics. So one example can be like we can see that so we want to find out the effectiveness of the medical procedures, okay? Effectiveness of medical procedures. So one group of people uh, uh, we applied like the medication only, and another group we applied the counseling only. In another case, we applied the medication and counseling. Medication and counseling. So that means then we have to think about, like, maybe the three procedure will be the same outcome, will have the same outcome. Or you can say some of the procedure has the better outcome than other. So in this case, we can define the methods, but those will be, the outcome will be the same. That means mu1 equal mu2 equal mu3. Okay, so outcome will be the same. Or we can alternately we can see that maybe there are some differences. It could be like A and B method are has the same effectiveness, and which is greater than the C. or method A actually more significant than more effective than B, and B is more effective than C. Or we can say we can have the relationship like this: A is more effective than C, but C and B and C has equally effective. Okay, so this kind of relation we can consider. Uh, so this is our null hypothesis. That means this null hypothesis means this: the three methods have the same effectiveness, and alternate hypothesis they have the different effectiveness. Now we have collected the data, and we can see that means we applied these methods. Here is of three peoples, okay, in three peoples. So you can see if when we apply the medication only, this is our individual 1, this is our individual 2, and individual 3. Individual 3. So when we applied the medication, then individual 1 consumes the alcohol 3 times, maybe per day, and consumer 2 consumes 2 times per day, and consumer 3 consumes the alcohol just 1 time per day. But counseling only, when we just do the counseling only without medication, counseling only on the uh, time, the per day alcohol consumption for individual 1 it is 5, for individual 2 it is 3, and for individual 3 it is 4 for counseling only. And if we do just both medication and individual 1 consumes 5 times, individual 2 consumes 6 times, individual 3 consumes 7 times, like this way. So now we can see here is a now we have to find out the individual mean. So here the individual mean, that means you can say here you can see that the medication only for this case consumption is 3, 2, and 1. So 3 plus 2 plus 1, that means we can say 6 by 3. So this is the mean, 6 by 3. And then 5 plus 3 plus 4 divided by 3, it is 4 for the method B. And for the method C, 5 plus 6 plus 7, it is 6. So these are the mean, okay? Mean value for medical group A, mean value for the treatment group B, and for there is treatment group C, here is the mean is 6. And then we have to calculate the grand mean. So grand mean in this case, grand mean there is 2, here is 4, here is 6. Okay, so 2 plus 4 plus 6 divided by 3. There is 6 plus 4, 10, 12. 12 by 3 is 4. Okay, so here the grand mean is 4. So based on those statistics, we will calculate our result. But ANOVA, we have to follow the ANOVA steps. At first, we have to find out the SS. That is total sum of squares. Here the total sum of squares. The total sum of squares, it will be the summation of xi minus of xg bar square. So here in this case, we can see that means for xi, this is one xi, and this is our xg bar. So it means xi is 3 minus of 4 square plus, the next is 2 minus of 4 square plus of, there's the 1. So that means 1 minus of 4 square plus of, this is 5. So 5 minus of 4 square plus Similarly, for 3 minus of 4 and 4 minus of 4, 5 minus of 4, 6 minus of 4, lastly you can say in this way, we have to add like 7 minus of 4 square. So this will be our total sum of a square. So total sum of a square you will get here in this case you will get the total sum of a square equal 30. Okay, so sum of a square in this way you will get the 30. And then step number 2 you have to calculate the total sum of a square within. So total sum of square within that means you can say uh, we have a test like the medical only this method. Within this we have to perform the total sum of square. So total sum of square in this case you can see xi minus xa square. So xi minus xa it means for this one for the SSW1 it is 3 minus the average. So average is 2. 3 minus 2 square plus the next one is 2. Okay, so 2 minus of 2 square plus of and then 1 minus of 2 square. So it means that here is 3 minus 2 is 1, 1 square is 1 plus of 0 plus of 1 minus 2 is 1 minus 1 square is 1. So it is like 2. So that means SSW equal to so you will get the SSW equal to if we do the math then it will equal also 2. Okay, so you will get those values. So then the SSW equal SSWA, SSWB and SSWC. It will be 2 plus 2 plus 2 that means 6. It will be 6. Similarly, what we have to do, we have to find out the DFW, the degree of freedom within. So degree of freedom within in this case we can see for uh, for our A, the degree of freedom is 2. That is uh, medication only. So here is the n minus 1. N is what? N is 3. The n minus 1 is 2. For our counseling unit, counseling only. Here is the n minus 1. That means you can say here is also 2. And for our medical and counseling, you can see n minus 1. So that means 2. So 2 plus 2 plus 2, that means 6. So here is you can say degree of freedom is also 6. So SS within, you can say SS within, it is the value is 6 and also DF, that is degree of freedom is also 6. So this is step 2. Next, the step 3. The step 3 it is we have to calculate the total sum of squares between. So between means one group to another group between. So this group and this group like this, and this group and this group like this. Okay. So here SSBA. So SSBA. In this case, we can see there is the NA is the number of individuals. So in this case, the number of individuals we can see 1, individual 1, individual 2, and individual 3. So that means 3 individuals. And XA minus of X bar G. So XA is what? XA is this. X bar G is 4 and a square of that. So it will be like in this case, and a number of people here is 3. Number of individuals is 3. And then XA is what? XA is 2 minus of XG is what? XG is 4. And here is the square. So that means it is 3 times 2 minus 4 is minus 2, square is 4. So that means it is 12. Just 12. Similarly, if we calculate SBB, then you will get 0. And for SBC, you will get 12 again. Now we have to find out SS between, okay, sum of squared between. So that means SSBA, SSBB, and SSBC. Okay. So on this case, we can see here 12 and 12 is actually 24. And we have to find out our SS, that is DF of B. So DF of B, in this case, we can see for within, we have three categories: medication only, counseling only, medication counseling, three categories. So that means n minus 1, in this case, 3 minus 1 it is 2. So DF B is 2. So now we have to move to our fourth step. We have to find out the F statistics. And the equation of the F statistics is SSB divided by DFB and SSW divided by DFW. So SSB in our case it is SSB is 24. So we have already calculated that. There is the SSB, SSW, SSB is 24. So that means here it is SSB is 24. Divided by DFW, we have already calculated it is 2. And SSW is 6 and DFW is 6. So it is like 12. So FA statistics we got 12. Okay, we got 12. FA statistics is 12. Now what we have to do, we have to find out now the F tabular value. Okay, F tabular value. And to find out the F tabular value, in F we need the F distribution table. And here we consider the significance is 0.01. Okay, 0.01. But we need here DF1 and DF2. What is DF1? DF1 is our DFB. So here is the DFB, degree of freedom of B. It is there is 3 minus 1 is 2. We have calculated already. And DFW we have calculated it is 6, which one is equivalent to DF2. So that means DF1, so DF1 in this case is 2. So DF1 in this case, this is the 2. And DF2, value of DF2 is 6. So DF2 is 6. And actually the value we got here 3.4633. 3.4633. Okay. So that means F critical value is 3.46. We got the F statistics is 12. F statistics is 12. So 12 and F critical is 3.6. 3.46. So that is 12 is greater than 3.46. 3.46. So if this is the case, then what we have to do? Then we have to reject the null hypothesis. Okay? Reject the null hypothesis. So we can say if test statistics greater than the critical value, then reject the null hypothesis. So we have to reject that. So if we reject that, that means this is the rejection. This is hypothesis. This hypothesis is the rejection. That means we have applied three methods: medication only, then counseling only, and then medication plus counseling. Three methods. Outcome of the three methods will not be the same. Okay, so that's the this is mentioned. Not the same. That means we can say alternate hypothesis. We can think about the alternate hypothesis. Okay, we can think about the alternate hypothesis. But now we can see that actually it just mentioned that which hypothesis is accepted, which one is rejected. But still, which one is better, we didn't find out that. That is whether the only counseling is better or whether only medication is better or both of the combination of both is the better. We didn't find out that. So currently we just find out that they don't have the equal impact. They don't have the equal impact. Now we have to find out that is which one is actually better, and for that we have to extend this one, our ANOVA test and apply this TAKI HSD test. Okay, TAKI HSD. So TAKI HSD means it is the honestly significant difference. Honestly significant difference we have to find out. And the HSD, here the HSD is this. This is the equation for the HSD. So honestly significant difference we have to find out. Hello, am I audible? Okay, so we can so here is the discussion. Then there is the q alpha here. This is the value q alpha. Uh, it's a value from the table, that is we say the student dice tables. So this value we will receive for finding out that this table value. We need the DFW, but we have already calculated the DFW, that is a degree of freedom within, and we found that it is 6. And then we need another thing, that is the K. K is called the number of groups. Okay, so in this case, we have number of groups is 3. Okay, so using our standardized table, we can find out our Q alpha. So here is our standardized table. Q standardized table, and in this case, we can see that the value of K. In our case, 3 groups we have, and that DF is 6. So DF is 6. This is a DF6. You can see that the Q value, it will be, the value of Q alpha, it will be 3.558. Okay, 3.558. So 3.558, considering the alpha value 0.1. So here is this. That is, you can see the 3 point. This value is 3.558. And then in this case, it is MSW. So MSW, that is mean square within group. So mean square within group, it is SSW. So we have calculated that SSW. This is actually, we got 6, and then DFW is 6. So that is 1. So that's why mean square within group, it is 1. And NA is the number of people in each group. So number of people in each group, we can see the three people we have, so equal 3. So if we put those values here, then we will get the SSD for alpha 0.1. and that is our 2.0542. Okay, 2.0542. 0542. So this is our SSD HSD value. HSD value. Now what we have to do, HSD is this, that is honestly a significant difference. Honestly significant difference is 2.0542. Now what we have to do, we have to find out the difference among the groups. So at first we want to find out the difference A to B. So you can see that average of A is, that is XA, is 2, and average of B, method B, is 4. So if we find out the difference, then 2 minus 4 is minus 2, and the absolute difference is just 2. A to C, group A and group C, on that case 2 minus of 6, and we can see it is 4. So absolute difference is 4. And B to C, here is the B is 4 and C is 6. So 4 minus 6 is minus 2. Here is it 2. So absolute value. Now we can see that our HSD value is 2.054. Now we have to find out the value greater than that. So we can see this is the value greater than that. That is the 4 is the value greater than that. So in this case, there is A to C. A to C. That means we can see C. Here is the negative. So that means you can see C is 2 minus 6. So C is greater than A. Or you can see C is better than A. In this case, we can write like the C is better than, so C, it has the significance. Okay, C has the significant difference because the value is greater than, the 4 is greater than 2.054. So that means C is greater than A. Okay, A, then A. And now we can see A and C here. So both of the differences, we can say another two differences the same, that is 2. So we can write like this one. That means method C's outcome is better than these two. Okay, so finally we can find out the exactly, that is which one is better using the Taki HSD test. Which group is better? Okay, so sometimes in our research we need to find out, like here you can see that is significant or not, and we have to assign the p-values, different p-values. Okay, so which one is significant, which one is not significant. So in our research we need to find out those things also. Then we have to apply uh, that is different kinds of test, ANOVA test, and the p-values also we have to mention. So that's all in our discussion of ANOVA. How many topics we have left? Um, I think I think uh, in our Saturday class you have to present your project. Yeah, yeah. I think this is the last class. Okay. Okay. Thanks everyone for joining this session, and see you in the next class. So I will post an announcement, and over there I will mention the syllabus in your final exam. Okay, thank you. Thanks everyone for joining.